In this video, we are going to solve question number 4 of exercise 1.1. The question is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So observe here, we have to take the square of any positive integer and we have to express it in the form of either 3m or 3m plus 1. Where what is m? M is some integer. Let's go through the solution now. First of all, we will consider a to be any positive integer, and for a, the divisor b is equals to 3. So we can say by Euclid's division algorithm, a is equals to 3q plus r, where 3 is our divisor, q is the quotient, r is the remainder. And over here, a that we have considered as a positive integer, it is our dividend. Q, which is the quotient, its value is an integer which is greater than or equals to 0. The possible values of remainder r would be equals to 0, 1 and 2, because according to the condition, the remainder has to be either greater than or equals to 0 and less than 3, less than the divisor. So let's look at the first case. Here we are considering remainder to be equals to 0. So we will write down a as 3q plus 0, which can be written as 3q. Now we have to take the square of this positive integer a. So on taking a square on both the sides, we will have a square is equals to 3q whole square, which will give us a square equals to 3q whole square will become 9 times of q square. Now from this we can take 3 common and write it down as 3 times of 3q square, which can also be written as 3 times of m, where m is some integer. So now we are left with two cases when remainder is equals to 1 and remainder is equals to 2. Let's look at those. So in case 2, we are considering remainder to be equals to 1. In that case, we can write down positive integer a as 3q plus 1. On taking a square on both the sides, we will obtain a square equals to 3q plus 1 whole square. Now, how to evaluate this? So we will be using a plus b whole square identity, which says a square plus 2ab plus b square is the expansion of this. Now over here, if we will compare 3q plus 1 whole square with a plus b whole square, our a over here is 3q and b value is 1. So we will substitute this in the expansion and we will obtain a square is equals to 3q whole square plus 2 into 3q into 1 plus 1 whole square. Let's simplify this. So we are going to get 3q whole square as 9q square plus 2 into 3q into 1 will give us 6q plus 1 whole square will give us 1 itself. Now, it is time for us to take 3 common. So we can take 3 common from the first two terms, 9q square plus 6q. This plus 1 will remain as it is. So we will be writing a square is equals to, taking 3 common from 9q square and 6q, we will write it down as 3 into 3q square plus 2q plus 1. So this entire expression 3q square plus 2q can be substituted as m. So we will write down finally as a square is equals to 3m plus 1. So in the second case, we observed that the square of any positive integer, we are able to write it down in the form of 3m plus 1. Now let's look at the third case where remainder is equals to 2. So in case 3, we will write down the positive integer a as 3q plus 2. Here remainder is equals to 2. So if you will take a square on both the sides, it will become a square is equals to 3q plus 2 whole square. Now same way we will be using the identity a plus b whole square in order to evaluate this. Over here if you will compare, a value we will consider it as 3q and b value we will consider it as 2. So on doing the expansion of this term, we will obtain a square is equals to 3q whole square plus 2 into 3q into 2 plus 2 whole square. On simplifying this, we are going to get a square is equals to 3q whole square will give us 9q square. 2 into 3q into 2 will give us 12q and 2 whole square will give us 4. Now, is it easy to take 3 common? We can't take 3 common from 4, right? So, what we will do? We'll split 4 in terms of 3 plus 1. Let's do that. So, finally, we will be writing a square is equals to 9q square plus 12q. This 4, we will split it in the form of 3 plus 1. Now, from the first 3 terms, 9q square plus 12q plus 3, we can take 3 common, right? So, we will write down a square is equals to 3 times of 3q square plus 4q plus 1. And this plus 1 which is afterwards, it will remain as it is over here. So, now we can see that we can write down this square of any positive integer in the form of 3 multiplied by some integer plus 1. So, let's write it down. Finally, we will be writing a square is equals to 3m plus 1, where m value is 3q square plus 4q plus 1. So, these were all the 3 cases where we considered remainder to be equals to 0 in the first case. In the second case, we considered remainder to be equals to 1. And in third case, we considered remainder to be equals to 2. And in the first case, we obtained the square of any positive integer in the form of 3m. In second case, we obtained it in the form of 3m plus 1. And in the third case, we obtained it in the form of 3m plus 1. So, what did we conclude? We'll write it down as clearly square of 3q, 3q plus 1 and 3q plus 2 are of the form 3m or 3m plus 1, where m is an integer. Hence, we can conclude that square of any positive integer is either of the form 3m or 3m plus 1. For some integer,